IGCSE, past paper, January 2017, paper 3H, and here's a few of the questions from there, worked through. Question 1, part A, you're given an average speed and in kilometres per hour, and you're given the flight time, find the distance. Well, we can use the formula for average speed, total distance divided by time taken. If we substitute into that, the average speed is 750, total distance, let's just call it D. Time taken now, be careful here, lots of people write 7.18 and get the wrong answer because it isn't 7.18, is it? It's 7 hours and 18/60ths of an hour. 7 plus 18/60ths of an hour. Now, or you could write a mixed number there, 1.5, we write as 1 and then just a half with nothing in between, but what we perhaps should write is 1 plus a half. This would actually be more consistent because when we put things next to each other in maths, it usually means times, except in this situation here. But that's just why I've written 7 plus 18/60ths there rather than 7 and then just 18/60ths with no gap. If you multiply both sides by the denominator, we get D. And if you calculate that, you get 5,745 kilometres. Part B, where it's a unit conversion. So start by writing out what 750 kilometres per hour means. It means you've gone 750 kilometres in 1 hour. Which, so to pick one of your units to begin with, we're working in kilometres, but we want to be in metres. So 750 kilometres is 750,000 metres. That's in 1 hour. Now that's 750,000 over 60 metres in 1 minute, because we're travelling for 1/60th of the time, so we're going to go 1/60th as far. And then, of course, to get from minutes to seconds, we need to divide by 60 again. And that's in 1 second. So the only thing left to do is to calculate what 750,000 divided by 60 squared is. 60 times 60 is 3,600. Work that out on the calculator, we get 208.3 recurring metres. Okay, then we jump to question 6. So it's finding an estimate for the mean. It's an estimate, of course, because we don't know the original data. We just know that these 28 people had somewhere between 0 and 5 kilometres to travel. But since we don't know the original data, we pretend that all of these 28 people had exactly 2.5, or the midpoint of each class. So we're going to kick off by writing down what those midpoints are, create a new column any way you like, there's usually space in between, and then multiply, we call that X for the midpoint and F for the frequency, create an XF column, which is the products of the rows. So 2.5 times 28, and then 7.5 times 32, etc. Now we need to add those up, 940, and then divide by the number of numbers, because we're finding a mean, aren't we? And before we go any further, just think about a couple of the meanings of these things. What does this 70 mean? That 70 is an estimate for the total distance that these 28 people went between them. 240 is an estimate for total distance that these 32 people went. This 940 is an estimate for the total distance that everybody went. So how many people are there? How many parcels are there actually? There's 100. It says it in the question, and you'll also find that if you add up these numbers in the frequency, you should get 100 there. So what a lot of people do and get it wrong is they do 940 divided by 5. That is wrong. Because what have they done? They've gone, there's 1 row, 2 rows, 3 rows, 4 rows, 5 rows, so there's 5 pieces of data. So we divide by 5. No, that's nonsense. You divide by the number of pieces of data. Okay, there's 100 parcels, 100 data. and 9.4 is our answer, measured in kilometres. Okay, question 7's next, ratio question, not a particularly challenging one, but I'd recommend you set these out in this particular way. We'll start by labelling the titles of your ratio. RMS is the order in which they appear in the question, and that's 4, 3, 9. And we're told that Mario gets £96. So to get from 3 to 96, we times by 32. You can just divide 96 by 3 to find out what that multiplier is. We have to do that to the other 3 parts of the ratio as well. Okay, once we've got that, so those are the amounts. That's how much money everybody receives. So now we go back and read the question carefully. Work out the difference between the amount received by Rachel, so the difference between R's value and S's value. Well, the difference between 2 values is the biggest, take away the smallest, so we just need to do 288, take away 128. And we get our answer in pounds. Now there is another way of solving this question. Just before we move on, I will show you. It's quite quick. What we can do, sometimes you'll see we have a total column. We don't need a total column in this ratio because at no point are we dealing with the total. But you can have other columns in your ratio by that are anything you like. So you might start by doing an S minus R column, knowing that you're going to have to do that subtraction at some point. In the original ratio, that's 9 take away 4, so 5. But then we can treat that 5 like we did all the other parts of the ratio, times that by the 32, and that jumps us straight to our answer of 160. Okay, hard to see the whole slide on this one, but you might remember the question quite well. Hopefully you've got the question in front of you on paper as well. If not, then not a problem. So we're asked to draw this graph, y equals minus 2x plus 4. Now you can do that by creating a table of all the values, because it says between minus 1 and 5. So I've gone from minus 1 to 5 integers for x. And calculate the y values. I always start with the y-intercept. We know that's 4 because it says it in the equation there. And then you can work out the other ones easily, and then you quickly spot the pattern because it's a linear sequence. And you can plot those as coordinates. But I think perhaps a slightly more grown-up way of doing it with a straight line is to again start by acknowledging that 4 there as the y-intercept and mark that on the graph here. And then what's the gradient? Gradient's minus 2. What does gradient minus 2 mean? It means for every 1 we go along, we go 2 down. For every 1 we go along, we go 2 down. For every 1 we go along, we go 2 down, and so on and so forth. That gives you all the new points that you need. So plot those, and don't forget to draw the line through them. And we've done part A. Now show by shading on the grid, this is part B now, the region defined by all 3 of these inequalities. Firstly, y is less than or equal to minus 2x plus 4. We've already got that line drawn. Draw that line, if it isn't already drawn. Y greater than or equal to minus 4, so draw the line y equals minus 4. I'm going to do that in green in a moment. And x greater than or equal to 1, well, draw the line x equals 1. I'll do that in a moment as well. So y equals minus 4 is there, and x equals 1 is there. And then before you jump and shade in the triangle, just check that that is indeed the bit that we want, because sometimes this is the area that's the region, or this one here, or that funny one up there. All of these are infinite regions, they carry on beyond the graph, or it could be this one down here. Now, as it happens, it is this one here on this question, and here's why. Looking at this equation, the positive y is on the left hand, sorry, it's on the less than side. Y is on the less than side, so we want to be beneath that line. Sorry, I'm just labelling the lines. So we want to be beneath the red line, so I'm going to draw an arrow pointing down on it Y is greater than or equal to -4. Well, y is on the greater than side, so we want to be above it. And x greater than or equal to 1, well, we want to be to the right of that, because we need to be bigger than 1, and bigger for x is to the right. So there. And all those arrows point into the middle. Now, you can shade the triangle, but I think it's better and more clear to shade everything but the triangle. And you can do either. In additional maths, they always ask you to shade outside. And they're not bothered for GCSE. So I'd do the same as the ab mathematicians and shade around the outside of it and then label the region as it asks for R. Great, let's move on. Question 9. Simplify that thing. Okay, here's my best tip. Simplify the two separate sections and then put them together. So 2x plus 3 all squared is 2x plus 3, 2x plus 3. Expand that using the normal method. And simplify the two 6x's in the middle to 4x squared plus 12x plus 9. Now let's look at the separate section here. And do that over here in red. Expand it in the normal way and simplify. Great. Now, in black pen, I'm going to subtract the blue, so I'm going to do the blue expression, subtract the red expression. So 4x squared plus 12x plus 9. Take away, and now we're taking away a set of terms, 1, 2, 3 terms. If you're taking them away, you need to be very careful and use brackets. Now we could use brackets here and here as well. Maybe you think that looks more symmetrical and better, but we don't need those. They're not actually doing anything, so I'm just going to get rid of them. So altogether we've got 4x squared take away 2x squared is 2x squared. 12x take away negative 7x is plus 7x, of course, so 19x, and 9 minus 15 is plus 24, and we're done. Reverse percentages question. The most intuitive way I can think of to do these is to go to create a discount of 18%, you take a normal price and you multiply it by 0.82, because reducing by 18% is equivalent to finding 82% of that original value. And when we do that, we know that we get £25.83 from the question. So looking at that equation, pretty straightforward to spot that we need to divide both sides of the equation by 0.82 to get our answer. Sling that in the calculator and we get our answer straight away. Just make sure in that situation that you round things to the nearest penny, but in this case we get a nice round number anyway, £31.50. Okay, this is tricky to squeeze everything on here, but again, hopefully you've got this open in front of you. Cumulative frequency, just check that you've read the whole question, especially note that you've got 100 people. Your cumulative frequencies, therefore, should end in 100. Great, that's easy, you just get 1 mark for those. When you're plotting along the x-axis, you're going to take this upper bound of each class. There's a good reason for that mathematically. Think about it and ask me if you want. I'll explain why we use the upper bound and not the midpoint or something. And for the y value, we just use the cumulative frequency. So if you plot those x, y values on the graph, there we go. Don't just leave it like that, or certainly don't plot a line of best fit. It's not a scatter plot, it's a line graph. You can draw with a smooth curve, but you always get the marks for joining up with straight lines, so join the dots with a ruler. And you get this. You actually get more accurate results. You get results that are more in line with what the mark scheme wants when you use your graph to calculate things. So finding the lower quartile, you might remember the formula for finding the lower quartile. It's the n plus 1 over 4th piece of data. But when n is large, or when you are using cumulative frequency, which we are here, you can ignore the plus 1 because it doesn't really have much of an effect proportionally. So scrap the plus 1. So we just need to find the n plus the n over 4th piece of data. N is the number of people. N always stands for number of objects in the survey in statistics. So 100 divided by 4, 25. So we're looking for the 25th piece of data. So draw a line along from 25 on cumulative frequency and down, and that gives us the value of our lower quartile, and that reads off at about 47. And then use your graph to find the number of these people who spend longer than 70 minutes in the coffee shop. Well, we can draw a line up, this time from 70 along to the graph and then along back to the vertical axis, and read that off at 62. Now just read the question carefully. It says people who spent longer than that, not less, because it's cumulative frequency. 62 is the number of people, roughly, who spent less than 70 minutes. So more than must be the rest of them, so about 38 people. And that's that. 12. Circle theorems. Common mistakes with this one. First one, most people get, they spot that we just need to do 48 times 2 because the angle at the circumference is half the angle at the centre, or the other way round, the angle at the centre is twice the angle at the circumference, and that's exactly the reason we need to write here. The angle at the centre is twice the angle at the circumference. Some people misunderstand the idea of giving a reason for their answer. Some people write, they just write the calculation they did in words. They say, so I took the 48 and doubled it and I got my answer. And they get no marks for that because that's not the point. The reason is the logical mathematical reason, and that requires you to learn and memorise the circle theorem sentences as they were given to you when you were taught this material. You have to learn those. There's no shortcut there. You've got to learn them. Angle ADC, common mistake with this one. People spot that it's... I'm just going to add my angle to the diagram now. People spot that there's a cyclic quadrilateral here, but they get the wrong rectangle. They get the wrong quadrilateral. People look at A, D, C, O, but that's not a cyclic quadrilateral. Cyclic quadrilaterals have all the points on the circumference. So you have to use A, D, C, B. Okay, and then when you spot that, the 96 is not actually relevant for this, for finding ADC. You just need to do 180 minus 48 because opposite angles in a cyclic quadrilateral add to 180. There you go, 4 marks. And then we have compound interest, really easy 3 marks if you know the formula. The possibly tricky bit is converting 2.75 into an increasing percentage. But of course that's going to be 1.02. If it was 2%, it'd be 1.02 to add 2% on. And if it's got values after the decimal point, just stick those on the end of the multiplier as well. So 1.0275. And then you literally just do 4,000 times that number, raise that number to the power 3 as you times it. Obviously don't raise the 4,000 to the power 3 as well. That would give you a staggeringly large and unrealistic number. It's just the multiplier we're raising to the power 3. Stick that in the calculator and we get a reasonable answer. Make sure you round again to the nearest penny to get the 4 marks. Proportion question, nothing particularly unusual here. It's a standard proportion question. T is directly proportional to root x. We write like that, T fish root x, which we turn into T equals K root x. That is our formula. That is the formula for T in terms of x, except we need to find the value of K. So out the way over here, I'm going to substitute the values of x and t that we're given into that template to calculate the value of K, which gives us 16, and then come back to your formula and give an updated version of the formula, a complete formula, and that's your answer. And just check that it does say a formula for t in terms of x, which is exactly what we've given, t in terms of x. Sometimes it wants x in terms of t, so you've then got to mess around and rearrange it. And then part B is so straightforward, it's barely worth me doing. You just have to substitute in your value of x. Right, more interesting question, similarity. So spot the word similar up there, similar. That tells you to use the kind of protocols you've learned to deal with similar shapes. You've got to learn these, you've got to do it the way I've told you in class. Because I see too many people making mistakes with these and it's careless. You follow my method, you get it right. You're given a volume ratio. So we write down volume ratio. Titles of the ratios, they're A and B, and the values we're given in the question are 264 and 891 cubic centimetres. Now, the extra information we're given is for A. So we're going to stick a 1, before we do anything with this ratio, we're going to put a 1 on the A side, because that's where we've got the extra information for. We're going to put a 1 here. If it's given as instead extra information for B, we try and put a 1 here. But it's for A, so we put a 1 here. It's a unitary ratio with a 1 there. And if you divide both sides by 264, you get exactly what you want. So just to simplify that, you get 27/8. That's a completely simplified unitary volume ratio. Now to get from a volume ratio to a length ratio, we cube root. Cube root of 1 is 1. Cube root of 27/8 is, well, cube root of 27 is 3, and the cube root of 8 is 2, so it'll be 3/2. Marvellous. Stick the 8 you're given in the question under the 1, and then think, well, 1 times what is 8? Obviously times 8. So you just do 3/2, or 1.5, times 8 to get this value here, and it's 12 centimetres. Part B, go back a few steps for part B. This time we're given a surface area, we're given extra information about B, so the 1's going to go on the B side here. But we're going to instead of starting with the volume ratio, we'll start with the length ratio, which is a bit more ground level. Length ratio, 1 to 3/2, as before, that's straight from there. But I want the 1 on the other side. Sorry, I've stuffed things up there a bit. Bear with me. There we are. Just go back a little bit. So yeah, I've put the 1 on the other side there. And therefore that'd be 2/3. So I've just divide both sides by 3/2, and you get 2/3 to 1. So area ratio, you're given the extra information, 459. Sorry, I've lost my train of thought. I need to square the length ratio to get the area ratio. So we square 2/3 and we get 4/9. Square the 1, we get the 1. Now we can substitute under the 1 for our 459 and times that by 4/9, and we get 204 square centimetres as your answer. Okay, this is where we got a brief insight into this a few seconds ago. Solve the equation that. It's a quadratic. Okay, solving a quadratic. We normally factorise, but look, there's a big clue in the question that tells you it doesn't factorise. If it factorise, things that factorise, like this, for example, have nice, easy numbers for x at the end. 3/5, 0.6, and -2, okay? We don't need to give those to 3 sig figs. If you need to give them to 3 sig figs, it simply won't factorise. So the nicest thing to do here is to use the formula, quadratic formula, which is in the formula sheet. Now, those are the A, B, and C, and if you just carefully substitute in and simplify slowly, you get everything you need. So just be careful there. Notice that, just go back a step, I've got minus 4AC. So minus 4 times 5 times negative 23. And those negatives are going to cancel out. Carrying on. Simplify that. Simplify it there. And then eventually just type those into your calculator and get your answers there. So just pause the video if you need to look at that for a bit longer. Copy it down. I'm going to move on. We're given another quadratic here. We're told it has a minimum point. There's 2 ways. So find the coordinates of the minimum. Well, minimum, think about the shape of a quadratic. And we're trying to find that minimum point. So one of the ways of doing this is to differentiate. Okay, Great, if we differentiate, we can see where the gradient is 0. Go through that method, differentiate. At the minimum point, the gradient is 0, so solve gradient equal to 0, and we get x is minus 9/20 or minus 0.45. And then we do need to substitute that back in awkwardly to find y. It's a bit of an awkward substitution. And there it is. We get positive 2.975. So give the answer as coordinates as it asks for. Okay. Now, the second method to get the same answer, which you might do instead, is to complete the square, because remember, completed square form gives us the coordinates, effectively, of this minimum point, the vertex, we call it. So, method 2, completing the square, or complete the square. Trick to do that when you've got a number in front of the x squared is to factorise it out of the first 2 terms, not all 3. We haven't completed the square yet. I know it looks a bit like it, but we haven't yet. And then just look in the inside. So ignoring the 10, ignoring the plus 5, just complete the square of everything inside the bracket. So we halve the number of x. So half of 9/10 is 9/20. And we square that, and then remember to subtract the square of 9/20. 9/20 squared is 81/400. Close brackets, and we still need the plus 5. I remember that from above. Now you can multiply these 2 terms in here, this square term and the minus 81/400. Multiply both of those by the 10. Still got the plus 5. That's not multiplied by the 10. And then you can finally combine these 2 terms here into a single number. And if you do that, you get plus 119/40. So now remember, from this is perfect now, completed square form. You can take x, the x coordinate of the minimum will be whatever value of x makes this bracket 0, so negative 9/20. And then your y value is just whatever this value is here. You don't need to change the sign of it. Sorry, I didn't mean to move on so quickly. This is the same answer as this. I've just written this one in fraction form and this one in decimal. They're both perfectly valid ways of answering that question. Okay, there's going to be a separate video for the remainder of the questions.